This is a solution to quiz 1. This is there were several different versions of the quiz, so this was the solution to one of them. In the first problem, the only thing going on is that I want you to use the fundamental theorem of calculus to evaluate a definite integral, and the only substantial thing that you need to do here is realize that we don't really have any of the basic rules that talk about the square root of x using that radical notation. Rather, we have the power rule, which talks about how to find an integral of x to a power. And so that's why you'd want to rewrite this problem first so that it just looks like number times x to a power. And so now we can apply the power rule for the antiderivative of x to the 1/2. Well, first of all, the 3 will be left alone there. The power rule says that we have to have a power that's 1 more than the original power. And you'll notice that when I do that, I just leave an empty space here because the number that goes here is supposed to be the reciprocal of this number. So I don't really want to think of that as 1 over something because I don't want to have to introduce compound fractions, but rather I want to think of it as just the reciprocal of whatever this power is. So in this case, the new power I have is definitely the 3/2 power, and so the number that needs to go in front is 2/3. Antiderivative of 4 is just 4x, and that's going to be evaluated from 1 to 4. I would probably go ahead and take the extra algebra arithmetic step here and cancel this 3 times with this 3 so that I don't have to have fractions running around anymore. So I have 2x to the 3/2 minus 4x. That's the antiderivative of the integrand, and that's going to be evaluated from 1 to 4. So when I let x equals 4, that's 2 times 4 to the 3/2 minus 4 times 4. And when I use x equals 1, that's 2 times 1 to the 3/2 minus 4 times 1. So here, this is 2 times 8 minus 16 minus 2 times 1, and then I have minus here, so that's plus 4. So in this case, I'll end up with 16 minus 2 plus 4, which is positive 2, as I was supposed to get. The second problem is not a definite integral, it's just an indefinite integral, so we don't have to plug any numbers in. And I'm asking you to do this by substitution. So when we do something by substitution, we use the fact that we know that the substitution is really just the chain rule backwards. So when we are looking to try to figure out what to substitute, if there's an obvious nesting of functions in the integram, then letting u equal the inside part is going to be the correct choice. So in this case, there is a 3x squared plus 1 expression inside of the cosine. And so this is a good choice for what we should let u equal. It's important to realize with integration that you don't always get it right the first time. It's quite possible that it looks like that a certain substitution will work, and then it just doesn't. And that's okay. Generally, there's only at most 2 or 3 ways that you could even imagine doing a problem. And so just being willing to give one of them a try and then go back and start again with another approach is just part of integration. So if u is 3x squared plus 1, then that means the relationship between the differential du, oops, I guess I'll go ahead and do that derivative. That one's not too bad. So derivative of 3x squared is just 6x. I'll just go ahead and do that there. So that'll be the relationship. Du is equal to 6x dx. So those are the 2 things that I'm allowed to use. I want to change equal things to equal things in the integrand, and I want to end up with everything back in terms of u. So those are the constraints, and then I just do my problem solving. So the first thing I would do is realize that the x that's sitting out here in front of the cosine could be moved over here to be in front of the dx. And the only advantage to that is that I can see from the stuff in my box that x dx is right there. And so in the box, that's telling me that if I see something that has x dx in it, then I can just change x times dx into something else. The way I like to do these, I would actually extend this and do an extra step here. Once I've determined that x dx is over in my integral, then I would figure out what exactly x dx is equal to. And now it's actually very easy to see how to match things up. I'll be looking for this guy to change it into a u, and I'll be looking for this guy to change it into a 1/6 du. And so you can see that my substitution actually happened where the stuff in the box, we just swapped out something for something else that it was equal to. And I've landed in a spot, I'll put this 1/6 out in front, I've landed in a spot where I have a new integral that only has u's and du's in it. So I can proceed from there. The antiderivative of cosine is just sine. And then I always want my answer to be back in terms of the original variable. So for my very last step will be to put 3x squared plus 1 back where the u's were. And so this will be my final answer. One thing to notice is that if you do check your answer, I did not want you to have to take time on the quiz to do that. A couple people did it anyway, which was great. But when you check your answer, one of the benefits of doing that is that checking the answer means to take the derivative of your answer and see if you get the original integrand. And one nice thing about it is that the main derivative rule that has to be used in checking the answer is going to be the chain rule. So that's the sense in which we mean that u-substitution is doing the chain rule backwards. So this is what the chain rule would say. Well, the 1/6 we would just ignore, we just leave it alone. The derivative of sine of something is cosine of that exact same thing. And then the chain rule says I have to multiply by the derivative of what this inside part is. And so I'm multiplying by the derivative of 3x squared plus 1. That's the step where you can kind of tell that you made the right choice, because that's what that's going to be your u from the u-substitution process. And that'll happen every time. So at the end there, that derivative of 3x squared, this thing, the derivative of 3x squared plus 1, that's just 6x. And so I'll have 1/6 cosine 3x squared, 3x squared plus 1 times 6x. My 6's can cancel, and then I'll have the original integrand right here that I get back as my answer.